sir.
Shall we start? Probably I know. You have textbook? You have textbook? But I don't have questions here. Can I tell you a textbook? Chettinad good exam is going on. Your exams are done. You have mobile, huh? So we'll get started. So write down the next heading as so write down the next heading as chapter 9, that is differential equations. Okay. So this is again a simple chapter only. So as the name suggests, no, it has something to do with differentiation and equations. So first, let's try to understand what is an equation. So for you to have an equation, you basically need a polynomial, correct? So how does a polynomial look like? If I have a naught x power n plus a1 x power n minus 1 plus so on till an, this is going to be a polynomial. But if I put an equal to sign and a zero, then it becomes an equation. It's called as a polynomial equation, right? So basically, what does an equation have? An equation has an equal to symbol, right? Suppose I write something like this: x square minus 3x plus 3 is equal to 0. Then this is called as an algebraic equation, or I can call it as a quadratic equation. Okay. If I replace x with sine, so sine square x minus 3 sine x plus 3 is equal to 0, then this will be called as a trigonometric equation. Right. In a similar way, if I replace then this will be called as a differential equation. That's it. So basically, it depends on what kind of parameters we are going to use in that particular expression. Right. So the parameters are going to be related to algebraic variables, you call it as algebraic. If it is related to trigonometric variables, you call it as trigonometric. If it is related to differential variables, you call it as differential equation. And this is the introduction, basic introduction to this chapter. And if you see the fifth chapter itself, you guys have already framed the differential equations. Right. Only thing is, at that point, you didn't know that it was a differential equation. So when you're framing a differential equation, when I talk about a differential equation, there are two parameters that are important. One is called as an order, and the second is called as degree. Okay. So for example, if I have, so one thing I would like to mention here is dy by dx can be written as y dash. I hope you know this, right? We have already discussed. D square y by dx square can be written as y double dash. So like that, depending on the number that you have here, you put those many dash on top of y, right? Suppose I have an equation like this: dy by dx is equal to e power x, right? Dy by dx is equal to e power x. Then this is said to be a differential equation of which order? This is a differential equation of first order. So how did I decide that this is a differential equation of first order? Is the number of times you have differentiated the function. See, for example, if I give you y is equal to e power x, then that implies dy by dx is equal to e power x. Am I right? So how many times did you differentiate it? Once. So it's called as a first order differential equation. For example, if I differentiate this again, d square y by dx square, that is also going to be e power x. Then what is this called as? It is called as second order differential equation. Like this, depending on number of times you differentiate a particular equation, you decide the order. ஆமா அவர் வீட்டுக்கு போயிருக்காரு. என்ன ஆச்சு? நீங்க நீங்க யாரு? ஃப்ரெண்டா? ஓகே. அவங்க அத்தை வீட்டுக்கு போயிருக்காரு. ஆமா, கால் பண்ணி. One minute. If I have an equation, so let's say I have an equation like this: d3y divided by dx3. Don't read it as d cube by d3y by dx3 plus 2 into d2y by dx2 the whole square minus dy by dx plus y is equal to 0. Okay. Now, if you look at this, then what is going to be the order of the differential equation? Order is, it is third order. So how do you say it is third order? Because the highest power you are able to see, the highest power or highest number of times it is differentiated, you call it as the order. But what is degree? So basically, degree is the power of highest order. So degree is what? Degree is the power of highest order. So what will happen is, here we'll get confused with the fact that d square by dx square is there, power 2 is there. So you'll start thinking that 2 is the degree of the equation. No, it is 1. Are you able to understand? Right. Those who are online, are you able to understand? See, it's a very, very simple thing.
Yes, sir.
Right? Yeah. So next is Suppose I have dy by dx the whole square plus dy by dx minus sine square y is equal to 0. What is this? So what is the order? Order is 1. What is the degree? Right. So look at the highest order. The power of the highest order will be the degree. Similarly, if you see dy by dx plus sine of dy by dx is equal to 0. This is an important one. Concentrate, okay? So dy by dx plus sine of dy by dx. What is going to be the order? Order is 1. But if you look at the degree, what is the degree? The degree in this case is not defined. What is the reason? What is some there is something abnormal with this equation? What is it? You wouldn't have sine x there. It is sine of dy by dx. So it is not a polynomial equation in terms of dy by dx. Hence, it is not going to have any degree associated. So here, whenever you have any function, any trigonometric, exponential, any function, instead of having x inside them, if you have a differential coefficient inside them, that for that kind of a function, degree is not defined. Okay. So here an important point to be noted is order and degree both are positive numbers. Basically positive integers. So order and degree are positive integers. Am I right? So based on this, what we will do is, we will try to solve the first exercise problems. Maximum time it will take is 10 minutes. So example number 1. So example number 1, find the order and degree if defined. So they have mentioned find order and degree if defined for each of the following differential equation. The first one is dy by dx minus cos x is equal to 0. Order, degree, second, xy into d square y divided by dx square plus x into dy by dx the whole square minus y into dy by dx is equal to 0. Order, 2, degree, 1, because highest power of the order is 1. See, the power of the highest order is 1. Third, order is 2 because second order is highest power. Second order the highest power is 1. That is why degree is 1. So next is y triple dash plus y square plus e power y dash is equal to 0. Order, 3. Degree, not defined. Because look at e power x, e power y dash, so it is not defined. Right. So based on this, let us solve some exercise problems. So the first one in the exercise is p power 4y divided by dx power 4 plus sine of y triple dash is equal to 0. Order, degree. Order is 4, degree is not defined. Second, y dash plus 5y is equal to 0. Order, 1 degree 1. Third, ds by dt the whole power 4 plus 3s into d square is divided by dt square is equal to 0. Order 2 degree. Degree is 1 because the highest power here is 1. Fourth one, d square y by dx square the whole square plus cos of dy by dx is equal to 0. Order 2 degree. So degree is not defined because cos of dy by dx. Hey, you're able to understand those who are online also.
Yes, sir.
Very good. So d square y by dx square is equal to cos 3x plus sin 3x. Degree. Sorry, order. Degree. Correct. Sixth one, y triple dash the whole square plus y double dash the whole cube plus y dash the whole power 4 plus y power 5 is equal to 0. Order. Order is 3. Degree. Correct. So degree is 2. Seventh, y triple dash plus 2y double dash plus y dash is equal to 0. Order 3. Degree 1. Eighth one, y dash plus y. Tell me that.
In the last question, seventh one, degree not defined, right?
Yeah. This is defined, huh?
Sir, there is no y or x.
Not necessary. See, suppose the question is y triple dash is equal to 0. What is the order? 3. Degree is 1. I'm saying whenever you have a function like trigonometric or exponential logarithmic, so in the function instead of having x inside, if you have any differential coefficient inside, for this kind of a function, degree is not defined. Purida.
Okay, sir.
Got it? Yeah.
Yes, sir.
So y dash plus y is equal to e power x. Order. Degree. Ninth. Y double dash plus y dash square plus 2y is equal to 0. Order. Degree. 3 more problems now. So d square illa. Y double dash plus 2y dash plus sin y is equal to 0. Order. Degree. 11th. D square y by dx square the whole cube plus dy by dx the whole square plus sin of dy by dx plus 1 is equal to 0. Order. Degree. 12th. Last problem. 2x square into d square y by dx square minus 3 into dy by dx plus y is equal to 0. Order. Degree. That's it. Okay. So I told you, this one is easy only, no? Now, the next question is about finding the general and particular solution of a differential equation. general and a particular solution of a differential equation. So, listen. What do I mean by solution of a differential equation? See, when will you get a solution when you solve something? For example, if I have dy by dx, let's take the same example. Dy by dx is equal to e power x. See, since everybody is a science student, right? In physics, how will you solve this? If you want, see, you have a differential equation and you want y, what will you do? From this, you will write dy is equal to e power x into dx. Am I right? Then what will you do on both the sides? You integrate. So when you integrate it, what will you get? Y is equal to e power x plus c. So I did this thing, dy is equal to e power x into dx. This is called as, this kind of right is called as variables separables. Okay, about which we have a separate exercise itself, fourth exercise. And this is the only way in which you can solve any differential equation. So for you to solve any differential equation, the only method is variable separable. So to arrive at that step, you will do different kind of modifications. That's a different story. But I'm repeating it again, in this whole world, to solve any differential equation, there is only one method. What is it? Variable separable method. Right. So when you did this, you got y is equal to e power x plus c. What did you get? Y is equal to, why did I get y is equal to e power x plus c? Because I did indefinite integration. So when I did indefinite integration, I got a constant. So I got the solution of the differential equation. Means if I integrate the differential equation, I got the function. So if I differentiate the function, I'll get the differential equation. Correct? See, for example, if this is there, I differentiate the function, what am I going to get? So are you able to understand? So if a differential equation is there, integrate it to get the function. So if a function is there, differentiate it to get the differential equation. Did you think, why are we learning differential equation after integrals? They didn't teach you the same concept during differentiation. So because you need the concept of integration. I hope it is clear till this step. So if you see y is equal to e power x plus c, the c is called as a generic value. So this is the solution. Y is equal to e power x plus c is the solution of the differential equation. Dy by dx is equal to e power x. So this solution is called as general solution. Whereas using some technique or the values, if I write y is equal to e power x plus 1, then this is called as a particular solution. So are you able to understand what is the particular solution? Particular means you know what is the value of the constant. General means you don't know what is the value of constant. Okay. So in this exercise, they'll give you an equation, they'll give you a function, and they'll give you a differential equation. What will they do? They'll give you a function on left hand side, differential equation on right hand side. You need to verify whether the differential equation that is given is actually formed from the given function. So basically, this exercise is all about differentiation. Simpler, if I have to say the way questions are formed, you will have function on the left hand side, you will have differential equation on the right hand side. Our job is to verify whether the differential equation that is given is formed by differentiating the given function or not. So having this in mind, the questions, I'll tell you how they will ask you. Okay, so there is an example problem here. Verify whether the function, listen to this, verify whether the function y is equal to e power minus 3x is a solution of the differential equation d square y by dx square plus dy by dx minus 6y is equal to 0. Means I need to verify whether this function will satisfy this differential equation. How do I do that? So in this exercise, whatever function they give you, whatever the function give you, first step, take it as 1. Then you have dy by dx. differentiated ones. So dy by dx is equal to minus 3 e power minus 3x. So since you have d square y by dx square, differentiated again, d square y by dx square is equal to minus 9, or sorry, plus 9 e power minus 3x. So what you will do is consider LHS, that is d square y by dx square plus dy by dx minus 6y. So d square y by dx another dx square is 9 e power minus 3x plus what is dy by dx? Minus 3 e power minus 3x minus 6 into what is y? E power minus 3x. Okay, but e power minus 3x is actually what? E power minus 3x is actually, look at the first step, e power minus 3x is y. So 9y minus 3y minus 6y. How much will you get the answer as? 0, which is the RHS. So what can you conclude? That the given function is the solution of the differential equation. Question? Other question? Right. Purida. Shall I proceed? Copy. Those who are online are able to understand?
Yes, sir.
Example 3, y is equal to a cos x plus b sin x. So y is equal to a cos x plus b sin x. Find whether this is the solution of the differential equation d square y by dx square plus y is equal to 0. So let's find out. How to solve this? How many times to do differential? So always take the question as 1. Y dash is equal to how much? Minus a sin x plus b cos x. Let this be 2. What is y double dash? Minus a cos x. So if I take the minus out, a cos x plus b sin x. What will this be? Y. So y double dash is equal to minus y, which implies y double dash plus y is equal to 0. Purida. Or see, if you don't get this idea, you can again take LHS. In the place of d square y by dx square, substitute this way minus a cos x minus b sin x. The place of y, substitute a cos x plus b sin x, they will get cancelled. Right? We are ready to solve 9.2. So exercise 9.2, the first one is y is equal to e power x plus 1. That is the function. And the differential equation is y double dash minus y dash is equal to 0. So question 1, what is y dash? E power x. Y double dash e power x. So take LHS. Y double dash minus y dash. So y double dash is e power x minus y dash is e power x. It's 0. Did you understand the algorithm, like how you are supposed to solve? This is the procedure. Very good. Differentiation. Substitute. LHS substitute, get the answer. Mostly satisfied. They ask you to verify, yeah, if it is not satisfied, then it is not a solution. As per your syllabus, mostly you have verify only, means it will be a solution. So y is equal to x square plus 2x plus c. And the given differential equation is y dash minus 2x minus 2 is equal to 0. So take the equation as 1. So what is y dash? 2x plus 2. See, actually what the answer? Y dash is equal to x plus 2. So y dash, bring this whole thing to the left hand side. Minus 2x minus 2 is equal to 0. புரியுதா? அப்படியே solve பண்ணா, or else what you will do is you will take this as 2. Again the same logic. LHS எடுத்தா y dash minus 2x minus 2. Y dash la what will you substitute? 2x plus 2 minus 2x minus 2 cancel. This will be equal to 0, which is the RHS. Simple. So third one, y is equal to cos x plus c. Y dash plus sin x is equal to 0. So y dash, so you take this as 1. Y dash will be equal to minus sin x 2. So what will you do? Y dash la substitute minus sin x plus sin x. Answer will be 0. Y is equal to root of 1 plus x square. Y dash is equal to xy divided by 1 plus x square. So what is y dash? So I'll take this as 1. What is y dash? 1 by 2 root of 1 plus x square into 2x. So 2 and 2 will get cancelled. X divided by root of 1 plus x square. Am I right? Then I'll take RHS for instance. Okay, so remember y dash is x divided by root of 1 plus x square. Let me call this as 2. So if I take RHS, xy divided by 1 plus x square. So this will be equal to x into, what is the value of y? Root of 1 plus x square divided by, you have 1 plus x square. So what will you get? X divided by root of 1 square. So which is equal to LHS. புரியுதா? So this problem, why did I take RHS? Because you have many variables and it is easy for you to substitute and find. First one, y is equal to ax. Xy dash is equal to y. So let this be 1. What is y dash? A, 2. So if I take the LHS, x into y dash, that is A. That is RHS. So sixth one is y is equal to x sin x, and the differential equation is xy dash is equal to y plus x into root of x square minus y square. So let this be equation number 1. So what is y dash? X cos x plus sin x. Am I right? So let this be 2. Now I'll take LHS separately. So if I take LHS, then I'll have x into y dash. X into y dash is going to be equal to x square cos x plus x sin x. If I take RHS separately, then it will be y plus x root of x square minus y square. Y is how much? X sin x plus x into root of x square minus y square is x square sin square x. Correct? So it will be x sin x plus x into root of, if I take out x square outside, it will be 1 minus sin square x. So x sin x plus x into 1 minus sin square x is cos x. That will be equal to x sin x plus x square cos x. So x sin x plus x square cos x sin x plus x square cos x, they both are matching. Here. Seven, xy is equal to log y plus c. Y dash is equal to y square divided by 1 minus x. So let this be equation number 1. Xy dash plus y is equal to 1 by y into y dash plus 0. Am I right? So this problem, what you can do is, instead of actually taking the right hand side or LHS of the differential equation, directly proceed by rearranging the equation. Y dash into x minus 1 by y is equal to minus 1. Or wait. This is right only. So y dash into 1 by y minus x is equal to y. So I'm taking this to the right hand side. So y dash into 1 minus xy divided by y is equal to y, which implies y dash will be equal to y square by 1 minus xy. Did you prove it? Clear? Eighth one. Y minus cos y is equal to x. And the function is y sin y plus cos y plus x into y dash is equal to 1. Let this be 1. So y dash plus sin y into y dash is equal to 1. So y dash into 1 plus sin y is equal to 1. So what can I write? Y dash is equal to 1 divided by 1 plus sin y. Let this be 2. Am I right? So if I'll take LHS. Y dash into y sin y plus x plus cos y. So y dash into y sin y plus, what is x plus cos y? Look at the first equation. What is x plus cos y? Y. So what can I take out common? In the place of y dash, can I substitute this? 1 by 1 plus sin y into 1 plus sin y. Can I write it like this? So 1 plus sin y and 1 plus sin y are gone. What is it you are having? Y. Is it not the RHS? Here. I'm not fast, no? You're able to understand. Good. Ninth one. X plus y is equal to tan inverse of y. Okay. X plus y is tan inverse of y. And the given function is y square y dash plus y square plus 1 is equal to 0. How to solve? Derivative of x is derivative of x is 1 plus y dash is equal to 1 by 1 plus y square into y dash. Correct? Yeah, derivative of tan inverse x is 1 by 1 plus x square. Then what is y dash equal to? Wait. See, sometimes you have these kind of problems, no? You need to think one step ahead so that you don't waste time in taking the LHS analysis. For y dash into, I'll connect the terms here. 1 by 1 plus y square minus 1 is equal to 1. So y dash into 1 minus of 1 minus y square divided by 1 plus y square. This one. So what will get cancelled? 1 and 1 are gone, which implies y dash into minus y square by 1 plus y square is equal to 1. Depend on that implies minus y dash or y square y dash is equal to 1 plus y square, which implies take it to the other side. Y square y dash plus y square plus 1 is equal to 0. Hence, proof. Here, copy it. Done. So next one is y is equal to root of a square minus x square, and the expression is x plus y into dy by dx is equal to 0. How to solve this? Let this be 1. Y dash is 1 by root of a square minus x square into minus 2x. Sorry, 1 by 2 into root of a square minus x square into minus 2x. Cancel this and this. Okay. So in the place of root of a square minus x square, what can I replace with? Y. So y dash is equal to minus x divided by y, which implies y into y dash is equal to minus x. That also implies x plus y into y dash is equal to 0. Breathe up. 11th. So the question is, the number of arbitrary constants, listen to this, the number of arbitrary constants in the general solution of the differential equation of fourth order. If I have y is equal to a cos x plus b sin x, no? So this a and b are called as arbitrary constants. So the number of arbitrary constants that are there in the equation is equal to the number of times you need to differentiate them. If a question, the number of arbitrary constants in the general solution of a differential equation of fourth order, what will be the answer? Score. Number of arbitrary constants will decide the number of times you need to differentiate. The number of times you differentiate will decide the order. So what about the 12th one? The number of arbitrary constants in the particular solution of a differential equation of third order. Listen to this carefully. The number of so 11th one, number of arbitrary constants in the general solution of the differential equation were 4. Whereas for the 12th one, the number of arbitrary constants in the particular solution of the differential equation of third order. Answer will be 0, because what solution is that? Particular solution. Particular solution, a constant is known. So if the constant is not known, you call it as arbitrary constant. If constant is known, you just call it as a constant. So answer will be 0. Purida. So this exercise is also over. I don't think third one is there. They have deleted it. Let me check. So you don't have the concept of formation of differential equation. In differential equation, you have order, degree, general, and particular solution. You don't have third exercise. That is formation of differential equation is not there. 9.3 is deleted. And I need not teach that because if a given function is there, you are expected to form a differential equation, which I have already done it in differentiation chapter. Okay. So I'll just give you the introduction of 9.4. And I'll do 2 problems. So 9.4 is about variables and separables, means how to solve a differential equation. So for you to apply this variable separables, you need a first order differential equation. And if the first order differential equation is of the form dy by dx is some function of x comma y, then what you're supposed to do is dy will be equal to f of x comma y times dx. And then integrate on both the sides. This is what is called as variables separables. Okay. So I'll just do an example and show. They actually theory la versalabu. Only thing is the concept. The only thing is you learn only through examples. So that's why I'm not stressing much. So dy by dx is equal to x plus 1 divided by 2 minus 1. Okay. So is this not a function of x comma y? Because if you look at the function, you have both x and y. And it is a first order differential equation. Can we separate the variables on either side? Observe 2 minus y into dy is equal to x plus 1 into dx. So when right hand side you have x variables and you have only x plus 1. Whereas left hand side you have y variable and you have only y variables plus 1. How can you integrate on both the sides? So on integrating both the sides, what will you get? 2y minus y square by 2 is equal to x square by 2 plus x plus c. That's the answer. But generally, how they will write is, they'll combine the equation and write it. So you can write it as x square by 2 plus y square by 2 plus x minus 2y plus c is equal to 0, which implies x square plus y square plus 2x minus 4y plus 2c is equal to 0. Okay. So this 2c you can replace it with some other variable also. You can write it as k because it's an arbitrary constant. So this represents the equation of a circle basically. Purida. So we'll do one last problem and wind up. If I'm fast, please let me know. So dy by dx is equal to 1 plus y square divided by 1 plus x square, which implies dy divided by 1 plus y square is equal to dx divided by 1 plus x square. So what should you do on both the sides? Integrate it. So integral of 1 by 1 plus y square is tan inverse of y is equal to, this is tan inverse of x plus c. So which implies tan inverse x minus tan inverse y plus c is equal to 0. Do you understand what is the meaning of this? This is called as the solution of the given differential equation. Are you able to understand what it means? Means if you differentiate this, you will get back the question. Is the point clear? So this is all about the introduction to this exercise. Problems will solve it in the next class. Okay. Tomorrow, how many of you are going to come online? There will other come here. Other using one person, it is difficult. It's better we have it online because none of them have come. We'll have it online. Sorry. So any other doubt? That's it. No? Those who are online, any doubt there?
No, sir.
Okay. Then we'll wind up. Okay.
Okay, sir. Thank you, sir.
Yeah.